Okay, part 2 of the video for chapter 5 review. So now we're going to get back into the normal distributions. So remember, if you're asked to calculate a percent, it has to say that it is normally distributed. So this one says the distribution follow an n. That n means it's normally distributed with a mean of 67 and a standard deviation of 4.4. Norm got a 66 on the exam. What's his percentile rank? So you do have to know a couple things. You need to know that means it's normal. You need to know what a percentile is. So there are 4 points. If you don't study for this, you don't get the 4 points. It's going to be problematic for you. I want to see a curve. I want to see a value, 66. I want to see an area. That is 1 point. You've got to shade the correct way. Now you need a z-score. So your z-score would be 66, subtract 67, divided by 4.4. That's going to get you a point for the z-score, whatever that ends up being, 2.2 or something like that, negative 2.2. So negative 1 divided by 4.4. Negative 0.23, actually. Okay? You need an answer in context. So the answer in context, you are finding an area, so you've got to use a normal CDF. So we're going to go menus 652. We're going to go from negative 0.23 to, whoops, what was the question? It's his percentile, so I did that wrong. We're going to go from negative 999 to negative 0.23. The percentile is the area to the left, so this should be about 41%. That's a point. But now you need one more point. You got to get the context. Percent is his percentile rank. That's 1 point. The answer itself is 1 point. Next one, Al scored in the top 7%. Top 7%. This is backwards. That's 7%. Remember, anytime you draw a line, it cuts that thing up into 2 areas. So we're going to use that. 93% is what we are going to use. This is an inverse problem. We have the area to the left. Remember, inverse norm only does the area to the left. This is going to find us a z-score. Our z-score is a positive 1.48. That looks like a positive 1.48 or a positive z-score. 1.48 equals x. Subtract 67 over 4.4. Now you can either solve it algebraically. We would multiply by 4.4, then we would add 67. That would get us an answer, 73.5 if we round that off. Or you can do it this way, menu 653, and you can put the 93. If you use the 7%, you will get this thing wrong. Okay, you can put in the mean and the standard deviation. It'll do the math for you. It's still going to get us the same thing, especially if we don't round. So 73.5. Context. Again, 4 points. 1 point here, 1 point for the answer, 1 point for the context, 1 point for the z-score, 4 points. Very consistent the way I score those for you. So make sure you get the different things. Okay, the next one. What information is needed in parts A and B to be able to use percentages? That's a key thing there. To be able to use percentages, you don't know it's normally distributed, you can do it. So that's the answer to part C. Nothing else is relevant. If you have a mean and a standard deviation, you can always do a z-score, but you got to know it's normally distributed. Okay, so the next one, number 6. We have a set of shirt prices. It's normally distributed. Good, because we're going to be asked about an area. Okay, so we're going to start. We're going to put the mean on here. The mean is 45. And then the two values are 37, which would be somewhere over here, and 59.47. Now, you can make it more accurate, but the important part that I have on here is that 37 is below the mean, 59 is above the mean, and I know I'm somewhere in between those two values. You're going to need 2 z-scores. A couple z-scores that we're doing. You have to calculate them. 37 minus 45, I'll do it for your sake, divided by, I don't know why it's negative 8. We could have found that out easily enough, but 5.5. That's our first z-score, negative 1.45. Second z-score. If you want to do it all in one shot, you can. You have to either put it in parentheses or create a fraction bar. This one has a z-score of 2.63. Okay, so now, menu 652. You got to have the value between those, negative 1.45 and 2.63 are our lower bound and upper bound. You can use the z-scores that you calculated. And this one is going to be 92%. Put the context up here, shrink it up a little bit. Sorry, it's kind of messy right now. I'm going to clean it up. 92% of the shirts are in the range 37 to 59.47. That's the final point. Again, we need all these points. We need one for the area, one for the 2 z-scores, one for the answer, and one for the context. All right, part 6. I'm going to cut that off because that one goes up here. What is the value of the shirt priced above 74% of all other shirts? Now, this is tricky. The shirt is above 74%, so that line would be drawn here. This is one that students tend to get wrong. We're going to shade this direction because the shirt is above the 74%. Okay, so this is an inverse norm problem, so we're going to go menu 653. We're going to do 74%. We're going to find that z-score is 0.64. We're going to write a z-score. 0.64 is our z equals x subtract 45 over 5.5. Again, so far we got 2 points because we have one for the curve, one for the z-score. Now we have to calculate this. So we're going to take that times 5.5, and then we're going to add 47, I think was the, no, 45 was the mean. So 48.53. I'm going to write it on the board here. I'm trying to type it. It takes too long. $48.53 is the value above 74% of prices. Again, one for the curve. Make sure you shade. You got to have it shaded that way. I did that with an arrow. One for the z-score, one for the answer, one for the context. Hopefully that's making sense. Okay, quick bonus review. These aren't on the review, so you may want to grab a sheet of paper and do this. I don't care if they end up getting submitted with your homework. That doesn't matter. But here, the mean is unknown. So we're looking for the mean. What is the mean? I don't know, so I'm going to leave it as mu. The standard deviation is 4, so that goes in here. 43% is above 108. 43% is above 108. I kind of know where my mean is. My mean is somewhere below 108. Okay, so first I'm going to have to calculate this because inverse norm only does the area to the left. So the area to the left is 57%. I use that 57%. To calculate a z-score, I get a z-score of 0.176. I'm going to go ahead and keep a couple decimals. And the 108 is my value of x, so that goes in here. Now I'm going to do a little algebra to solve that thing. Okay, so in solving that, I would multiply by 4. Sorry, I'm going to move this down here. I think that's 0.704 equals 108 minus the mean. I'm going to make sure 0.176. 704. Okay. Now I'm going to subtract 108 from each side. And it gets me a negative 107.296 equals a negative mean. Well, then my mean, I'm going to make both sides positive, and my mean must be 107.296. It makes sense with my drawing right there. It's below the 108. All right, next one, another bonus review. The mean this time is 1,200. Sorry, I got a timer going off here. All right, I'm going to finish out here though. The mean is 1,200. My standard deviation is unknown. So this time I don't know sigma. It says 3% is below 1,000. So I have to figure out what that z-score is with 3% to the left. Again, inverse norm only does the area to the left. So I get negative 1.88. Now I got to solve. Negative 1.88 times sigma equals a negative 200. Now how did I get that? I multiplied both sides by sigma to get sigma out of the bottom. Now I simply have to take negative 200 and divide by this prior answer, negative 1.88. I kept all the decimals for those calc students out there that like that. And the standard deviation is 166.3. Okay, now continuing on, number 7, a machine creates ball bearings with a mean of 4 centimeters. The standard deviation of 0.11. If a ball bearing is larger than 4.018, it's too large for use. What percent are too large? We're going to have to create a z-score. We're looking for a percent, so that means we're going to use inverse norm. First, we'll find this z-score. Z-score should be 1.64. Then make sure you get the idea. I'm going from 1.64 on up. So my normal CDF about 5%. 5% are too large. Okay. Next, the machine is fixed, and we've changed the amount to 2%. So this up here is 0.02. Okay, everything else remains the same. What does that mean? Okay, this one is real common that I put on the test. There'd be 98% of the curve down here. So first, I'm going to find this value of 98%, and that's a z-score of 2.05. So that's my z-score. Everything else remains the same. So in other words, 4.018 is still the value that's too large. The mean is still 4, but it says, what's the new standard deviation? So all you're doing is you're putting this information in to solve for it. I'm going to multiply both sides by the standard deviation. I get 2.05 sigma equals 0.018, and I just got that by subtracting those two. So I'm going to divide by 2.05, and that's going to get me my new standard deviation by taking the difference there, 0.018, divided by 2.05. And my new standard deviation is 0.009. Okay, last one. Now these are percentages, but just because they're percentages, that doesn't mean you're automatically doing an inverse norm. The mean of the test is 84.2. The standard deviation is 12%. What percent scored below 70? So this one, it's deceptive because this one is a normal CDF. It's just taking the value of 70, treating it like a number, subtracting 84.2, dividing by 12, finding that z-score. That z-score is negative 1.18. And then we're finding the area to the left. So the area to the left is about 11.9%. So 11.9% scored below a 70%. Okay, thanks for watching.